Hey, we are recording this session. So just so you know, uh, I said it twice before the recording started and after the recording started for the purpose of legality. You probably know this, or maybe not, but you don't care. I just want to let everybody know that we have to tell everybody that we are recording. You probably know this. There is a law apparently that I have to follow. So yes, we are recording this session, just so everybody knows that we are doing it. Okay, having said that, we are beginning a new section, which is this cloud architecture segment. And the comments that you had, which is, Amazon seems to be complex, and the examples that we have been using are simpler. Totally correct. Yes, it is by design like that. I will also show you an example of a case in which the last exercise we did, I think we had that chat session with Raj suggested that you do the same thing in this exercise of creating. Let me open that file and grab it. So I'll talk more specifically about what I'm talking about by opening up in an Atom editor and comparing, contrasting about what we are really discussing. So for a simple thing to create a box in DigitalOcean Cloud using Knife EC2 Server Create, it does not take that lot of detail. But if you do the same thing in a VPC, it requires a whole lot more detail, something like this. As you can imagine, it expects you to provide flavor, image type, availability zone, user, subnet ID, security group ID, the name, the roles you want to use, then a gateway. You might have a tunnel or a bastion machine. You have to provide that access to that machine. And then connection attributes to be using private IP address. So if you have a scenario where you are creating a machine in the cloud inside a VPC where you have a setup something like this, you have this configuration and you have another one in the private subnet, and you have this box sitting here somewhere. So let me make it up in the send to, this should go back and backwards. Yeah, and so this should be not yet send to back. There we go. So this machine that I want to create using Chef, cancel. Go back to the Curio editing there. Huh? What is that? Yeah, here. So if I want to create a machine back in my private subnet, and I am here on the public subnet. Actually, I'm outside somewhere here. And I want to create a box in there, in a private area. I need to go through a bastion machine, some kind of a tunnel machine that I have here, right? You recall this discussions we have had. We have created this configuration on our own, if you remember that, right? We had a public and private subnet inside a VPC area, and we were able to, go like this and then jump through this into the machine inside. We were able to create this by hand. If you want to do the same thing in a Chef scenario, imagine the complexity involved. You are basically looking at this, dealing with this tunnel machine, creating this new box that I want to create, and run Chef here. That's what I would like to do, for example, or run Ansible there, or some other code I want to be able to run inside that remote internal subnet, private subnet. If I want to do that scenario, then it requires a lot more level of detail to be provided. For example, that box internally will have a private IP address, not a public facing address. It will be something like 10 dot address as opposed to 52 dot. This line number 15 will be the one that matches the tunnel machine. And this tunnel is the gateway to the virtual private cloud that we have. So that's the tunnel box. We have a public IP there. This is the public subnet. And similarly, we'll have to have a production environment called out, the roles defined, the tag name provided, identity file called out. These are not new, but lines number 7 and 8 are new. We did not use them before. And so you have to provide a subnet reference, a reference to security group IDs inside, and also call out the availability zone you want to use, whether it is 1A, 1B, 1C, or like that, and whether it is east or west. You have to appropriately choose the machine image and then go creating a server. And so compare this with something like DigitalOcean, it was a whole lot simpler. It was something like this. Go here, click, and here. And you probably have done this. I don't need to show you the simpler version, but this is definitely more complex. And if you begin with this example, people don't understand, don't actually digest the whole thing. But having done the DigitalOcean thing first, then you basically get rid of some of the complexity, like you forget this line, that goes away, these lines go away, this is not needed, this is also not, actually these two are not needed. This image name complexity is simple, it is just called Ubuntu or something like that. The tag is not required, this tunnel is not required, this line is not required. So it's a whole lot simpler setup. If you go this direction, people find it easy to understand the concept. That is the whole goal of my program, is to make people understand. Once you understand it, and those of you who actually want to extend what we have done, and go and ask me questions. Hey, how do I do this in Amazon? Or how do I do this in XYZ cloud? And so then we answer that like this. This is how you do it. And now you know. Probably you have done it already in Amazon and it may have succeeded. Or maybe not. If you did not succeed, do it again. Let's do it again one-on-one. Because not everybody is interested in in this level of detail. But some of you are, and I welcome that.
Yeah, Nilesh, I'd be interested to do this. I don't know
one-on-one. Yeah, absolutely one-on-one. Make sure you do that. Don't skip the opportunity. If you are interested in something specific, let us do it. And so I don't want to spend time in the full class with 12 people sitting, listening to a complexity they may not be interested in. That's why I don't do this in a full session, on a regular scheduled session, but one-on-one is welcome. I've been telling you all along, and you've been using it. Use the one-on-one opportunity you have. And if you want to go in a specific direction, you want to explore, dig deeper, please do it. I will do it with you. Okay.
I'll pick a time and send you an invite.
Yeah, don't even have to go invite. I'm sitting here all day long. Just chat with me and we'll do it. Don't be formal. I'm sitting here doing nothing. I mean, I'm doing specifically helping you. That's what I do. And so don't have to be formal. Just chat. Hey, can we do it now? And say, yeah, go ahead, do it. That's how I work. I mean, I am here for you. You don't need to schedule me. I'm not a schedulable resource. You can just call me. Hey, can I do it now? And yes, the answer is mostly yes, unless I'm outside on the road driving or something, which is difficult.
Okay. I'll send you a ping on Slack chat then.
That works. Okay, let's begin, or rather start a new session. So where is that? Notability here. Notability. Okay, so here is our whiteboard, my preferred whiteboard that I've been using. Oh, this is the wrong one. Okay, which is the right one? This one. Okay. Yes, this is the right one. So now I have the right whiteboard and let's proceed. We have, okay. People still trickling in. So we are going to discuss cloud architecture in this segment. And what we intend to do is stay focused on customer usage. So usage can be varying from all the types of businesses. Here the user is basically business entities. Business entities that make use of cloud resources to do what? What do? They want to run some service, run some applications. That's what they really are doing in the context of a business. Those are the primary customers of cloud, and we want to understand what kinds of cloud architectural solutions will fit and address that need of this entity, which is the customer. And that's the premise that I begin with discussing this thing. So now, understanding. By the way, there are some videos for you to watch, like usual. There are not many, but some of them are actually long. So I just want to point out that pre-recorded videos that I have here are some of them are really old ones. So this is like a 19-minute long video. It can be dated. I'm just cautioning you. These are dated videos because they are probably 4-year-old or something like that. I don't know how old these videos are, but they're there. I would like you to watch them later on. What I would like to begin the discussion is to staying focused on understanding what are the business requirements for cloud computing. Like, how do customers think about the idea of understanding what applications do we focus on and what we work on, and in the context of a large business, so specifically a business scenario. And there is this video. In that video, there is a typo. It should be the word complementor, not I, but E. There are two different words. In the video, apparently, I have written the wrong word. So I would like to point out that we're talking about this E word as opposed to I. I is not the correct one. That's a typo, but I pointed it out. So watch that video. But I will describe this concept to you right now, beginning with a reference to a book by Adam Brandenburger. This guy, Brandenburger, he wrote a book. A book is called, is the right person? I think he's the right person. And so he writes books. And one of the books that he has written is called Co-opetition. And that is this book. And this book is available on Amazon. And he's a Harvard professor. And I bought this book in 2001, apparently. I have the book here, but you should buy it. The book is available for 1 cent. You should absolutely buy it. Maybe $4 extra for shipping, but it is pretty much cheap right there. It's a very good book. It is actually a book on game theory. In that book, there is a frame of reference for discussion defined. That's what I would like to begin discussing. And so that book was called Co-opetition. It is a combination word. How many of you have heard that word before? The words like DevOps combination again. This word is co-opetition. Did I discuss this word before with you at all, ever? Never? Okay. So did I spell it right? No.
No, but it has been in the industry for quite a while. But
Correct. So this word is not new as such. It is a established word. The idea essentially comes from two things together: cooperation and competition. So these two things together is how most businesses run these days. I mean, it has been like this forever, but people have realized, because these people like Adam Brandenburger come and coin that word. These two guys, Adam and Neil Buff, these two people wrote that book together. And the underlying idea is that people, especially companies, businesses, cooperate and compete at the same time. How can that be possible? Like, I would take some examples now. Examples would be, let's take the example of PC manufacturers. Who manufactures PCs? Dell, HP, Lenovo, like that, right? So are these guys competitors or cooperators? What do you think they are? From the point of view of an end customer, they are competitors, right? They fight with each other all the time, apparently. But there is one perspective that I have seen myself personally, personally involved in discussions, where I find that these guys are best of buddies when they used to talk to me. Why is that so? By the way, I was talking about me at Microsoft. They will negotiate together. I mean, they'll come together, form a coalition, and negotiate with Microsoft. And so this is Microsoft. And these guys are banding together as best of buddies that you would ever imagine. Why does that happen? Do you know?
they have a shared interest in.
Yes, shared interest. The idea is shared interest is to squeeze money down on the Windows license, right? Microsoft Windows that you have a product. So you want to squeeze down the price of that license as low as you can get, so that everybody stands to benefit with a cheaper license fee for Windows. And then they can sell to different customers that will use a PC running Windows, because now Windows cost went down because they all band together and compete. Later on, they compete among themselves. But when they discuss with us, I mean, us, I should not say us, discuss with Microsoft, at that time, they will be best of buddies you will ever imagine. The very next moment after the meeting is over, they go out, they start fighting. I mean, fighting for, just figuratively speaking. But essentially, they operate like co-operators. They cooperate, they compete. At the same time, the same people, they talk one thing in one topic, they cooperate, another topic, they compete. So to discuss this kind of a framework of thinking, it applies, by the way, to everything that we do in the business. In any industry, the same concepts apply. And there is a framework that we should use to discuss these things. And that is what I'm going to describe to you. It's a simple picture of 5 circles. And in the middle is the company that we are talking about. So for example, this is the company I would call the Windows company. Microsoft is too big to discuss in terms of a big company, because Microsoft also makes Surface these days. So it dilutes the picture a little bit. It makes it really complex. But from a maker of Windows, let's say, maker of Windows. So that's the company that I would like to talk about. Now, these guys produce a product and sell it to the customer. And there are these suppliers that supply the components to the company. And then there are these guys that cooperate with these guys. And these guys compete. So that's the framework to discuss. Now let us take some examples. If I am in the business of making sugar, and I want to sell my sugar, what do I have? Who do I have here in this circle? And in this circle, who do I have? So the competition, who do I have that competes with sugar? Splenda, as an example, right? Who do I have here? And who are the suppliers to me? Like sugarcane manufacturers, for example. And then in here is the people like you and me that that consume the sugar component, right? Whatever we sell. So who are the guys here? Do you know? So let me define this word called cooperators. I simply said the word cooperators, but the economic term for that is complementors. And that's the word that I would like to use. So, the fact that this complementor exists, the fact that they exist in the ecosystem makes sugar more interesting to the customer. What is that thing? The complement with the E there. So, do you eat sugar for no reason? You probably don't. I mean, kids maybe do it, but most of you don't eat sugar for the sake of eating sugar. So what do?
Candy bars and things that use your product as part of it.
Right. Anything that you add sugar to, right? For example, tea and coffee. These guys that make tea and make coffee are your complementors. Because the moment you have coffee with tea, with sugar, the product combination becomes interesting. This combination of coffee with sugar becomes interesting to the customer. That's how you think about complementors. So now let us look at a company called Boeing. Boeing makes planes. They sell these planes to the customer. Who's the customer? Is that you? No, you're not. Who are the customers? They're companies like Emirates, airlines, or the military, or things like that. These are the real customers of Boeing, for example. So I'm just picking on Emirates. Who are the suppliers to Boeing? You have GE that makes engines and some things of that nature. So so seat makers and I don't even know what goes in, but I'm just saying that these are the people that provide. They're the suppliers. Now, where do Boeing employees fit? Employees. Where do they fit? Do they fit here? Do they fit here? Do they fit here or here? Are they here? Probably not. Not employees don't go there, right? They're not buying airplanes, so they don't belong here. They are not competing with Boeing, otherwise they would not be employees. So they are not here either. They're not selling a product that makes a plane interesting, so they're not here either. They're not here either. So where do you think employees belong in this picture? Anybody? I would put them in here.
Yeah, suppliers.
Yeah, as suppliers, because what they are doing, employees are doing, is essentially providing their services, their time, their energy, their intellect, their capability, their skill to the company. You might think that you belong here, but no, let me tell you, you don't. The shareholders of the officers of the corporation that own that entity, not you as an employee of that company. You don't. You are a supplier. You're basically selling your skill and you're getting paid. That's the transaction, right? You give your skill, your time, your effort, your energy, your interest, and everything that you have, and in return you get salary, the compensation. That's the transaction. You give a plane to the company and you receive money from them. That's the transaction. Here, there is no transaction. I mean, this is competition. Who are the guys in this segment? Who sits here? What is it that makes a plane really, really interesting to Alaska Airlines, let's say? Alaska Air. They want to buy a plane, and Boeing has planes, so Boeing wants to sell a plane to Alaska. What is it here that may make it interesting to Alaska? Suddenly, this plane becomes really interesting. Who are these guys?
Competitors.
The competitors are here.
Okay. Complementors.
Yeah, they are complementors. So give me an example of a complementor. Who would that be with an E here? Who would that be? That mere existence, just the fact that they exist, becomes, by this plane becomes really interesting to Alaska Airlines. What is that?
Like travel agents?
That's for a level higher. So you have, this is you, and a travel agent will help you buy a ticket from Alaska Airlines. Right? This is you buying a travel ticket, a seat on the plane. So the travel agent will help you make it easy to buy. That's absolutely right, but it's in a different context. The company is Alaska Airlines, and you are the customer, and your travel agent like Expedia.com makes it easy. Great. Who are these guys? They make a plane suddenly very, very interesting. And those can be people like GE Capital, for example. People who provide loans to these guys. Now, I removed the name Emirates and put Alaska Airlines there for a specific reason, because Emirates doesn't need loan. They have so much cash that they just buy in cash, probably. But these guys will need loan, so they will borrow money from GE Capital. And the fact that they have, GE Capital available to them, the plane becomes interesting. So that's the picture from a Boeing's perspective. Now, why are we discussing these things? We are discussing these things for a specific reason. If you work for a company and you are obviously, as I said, a supplier, but effectively you operate like an agent of the company. So you're acting like an agent here. So you're practically here, but actually you're a supplier. So having understood that distinction between being an agent of the company versus the company itself, if you are acting on behalf of the company, being an employee, what you need to be worrying about from an IT standpoint is what applications, services, products that you might have in your IT portfolio that you should stay focused on, making sure that you are putting your company's resources in the right direction, not spending unnecessarily, but taking an inventory of all the types of applications that your organization may run. And large companies have a variety of different toolings, things that you deal with on a daily basis, on a continuous basis, I would say, or something like, I'd like to pull up my slide deck for a change and identify a couple of examples. So this picture that I just discussed is what I would like to go through is give you some illustrative examples of types of different IT applications that fit into these 4 circles around the company. There are IT implications of what we just discussed. The idea is to stay focused on those circles around you. I mean, these 4 circles I mentioned: the cooperative circle, the competitive circle, the customer circle, which is where the most of the attention is towards this segment. So the company needs to run a variety of IT applications to address the need of this circle, the need of this circle, the need of this circle, and internal requirements, regulatory requirements, all those things that are needed to be met. And at the same time, keep an eye on the competition. So these are the kind of critical applications that we as a company need to address. Make sure that they are functioning so that it eventually helps us run a good business. So I will now begin discussing in this segment here what types of applications typically companies will run. So for example, in that segment, in this sheet, I have a list of things that apply to the customers. When it comes to customers, what types of applications most companies typically run? They are, something like customer relationship management that involves dealing with customers, like salespeople engage with them, other people engage with customers. You want to know who the customer is, what their sales pipeline looks like, and how do you go and making sales, the transaction happen so that you keep generating revenue for your business. That requires CRM. So there are a variety of solutions available in the industry. CRM is a big domain. The most well-known company for CRM is this company called Salesforce.com, whose stock ticker symbol is CRM, by the way, and it is a software as a service. That is what Salesforce began when it did, focusing primarily on the actions, focused on the customer, and this is what probably as a CRM solution. But this is not the only one. There are many such companies that actually operate like that. Siebel Systems is one of those that I used to work in that company for an internship a long time ago. Siebel.com has been acquired by Oracle. So Oracle these days is a big name. Of course, it was always a big name, but the acquisition that Oracle did is another, I don't know why, yeah, it opened up. So this is the Siebel CRM solution that many companies deploy. And like this, the focus that I am trying to get your attention on is to address the need of the customers. We have to have a variety of things that interact with the customer running in our business to make customers happy continuously, not just from the discovery of what a new product is. So we create a new product, let them discover it, let them identify that it actually is the right product for them. Then you make a sale transaction, then the sale happens, then you go and help them use it. When in the case of using that product, they might need some service. So all these aspects, all the way to the end of life of the product, all these things that people do with a product, the beginning of a new idea, new product discovery, identification, sale, use, and service, that end-to-end game, you typically in large companies have some kind of an application that addresses that need. And so these are the types that I think are relevant, that most companies, and you probably know these things by at the back of your mind. I'm just trying to put a framework in the shape of this chart that highlights the need for us to stay focused on these 4 circles around us as from a company standpoint, and develop solutions that address our customer needs. Similarly, the needs of our competitors. What is our need from a competitor? Is to stay focused on what they might be doing to try to predict and preempt them and essentially become more successful than they are. So we need tools like competitive intelligence, for example. Some analysis tools like market intelligence are understanding trends in the market and being able to have a situation where we can actually beat the competition. The core thing here to stay focused on is to remain in a situation that you are doing your business legally in every country. As a large corporation, you may be doing certain things in certain countries which may be unlawful in other countries. So you have to keep an eye on what activities are considered competitive and legal versus competitive and illegal. There are certain boundaries that you should always take into account as to what applications you may be running in certain countries that may not be lawful in that land. So you have to keep that in mind when it comes to competition. Like, in certain countries, certain laws allow certain things that you have to understand from a legality perspective. This is the most tricky part when it comes to legalities, just calling that out. Next one is suppliers. And in this perspective, what you will look at is the idea of understanding supply chain management. So think companies like, what's that thing called? I2 Technologies. Yeah, this is I think they're a part of some other company these days. But JD Edwards is a solution for providing supply chain solutions. Oracle, again, is the king in the industry for any type of these solutions that I'm talking about. These are primarily business applications that people need to run in the context of a where did that go? Here, in the context of suppliers. You have to have supply chain management, understand inventory management, make sure that your employees are taken care of. So you have human resources management also in the same picture. Maintaining your end-to-end supply chain pipeline for just-in-time delivery to the end customers. All these aspects come into play when you want to run these applications. Next one is the complementer, the circle that helps you. When the mere fact of having a complementer help you is the idea, where the scenario will be something like, going back to the Dell, HP, and Lenovo example. When it is HP and Dell, they might be appearing to you as competitors, but they will act as buddies when they negotiate with Intel, because they want to bring the price of a processor down as much as they can. Or anything that they buy from Intel, they would like to negotiate together. So that has to be kept in mind when you need to have a system in which HP and Dell people can interact, collaborate, share information from a cooperator standpoint. Basically, identify a method where you can collaborate with partners in your company so that you can maybe do something specific, joint effort towards accomplishing a goal. Another scenario of a classic partner will be you do joint go-to-market planning, run a marketing campaign to drive a product that, if you are making tea and coffee are, by the way, competitors among themselves. If you drank coffee, you may not want to have another cup of tea right away. So it makes it less interesting. But sugar and tea is, cooperators. Coffee and tea are cooperators. The same ideas apply here. So the idea would be, from an IT implications perspective, make sure that you have systems in place that help your cooperators interact with you, do business with you. And there are specific tools in the market available to enable these functions specifically. You probably, in your companies, you have them already. And within your company, for internal and external compliances, business operations, internal operations, you will have a variety of applications running again. Of course, similar things about providing hardware, software, internal services, ensuring security. You will have systems to enable those things internally to your company. And now the bottom line, why did I discuss all this? The reason I discuss this particular structure for you is to remember one thing. In your company, you will have, and very likely in big companies, you will have scenarios where you will have applications that do not fit into any of these buckets. And I would like you to critically evaluate and even have after due analysis, have a method to say, no, we will not do certain things, not implement certain products or processes or services that do not actually help anybody in the game of business. This picture illustrates the game of business. A classic business is, by the way, the book defines, this book says, actually it's a part of game theory. Game theory is not about games, but about how businesses play games. And the idea of cooperation is part of game theory. And that's why I'm saying when businesses are playing games, they're essentially playing in this framework. So if you have some application in your company that doesn't help your customer, doesn't help your suppliers, doesn't help your complementors, doesn't help anybody in the company, think critically and don't do it if it doesn't fit in the picture, doesn't help any customer. Don't implement it at all. Maybe it's a good idea to drop it and not do it anymore. As I know, many companies are in the process of re-evaluating and migrating their businesses and their applications to the cloud. And so therefore, this time when you do it, I think it's a critical thing to remember that if something doesn't fit in the bigger picture and doesn't help any of the constituents, let's think about dropping it and not carry our unnecessary legacy forward as we migrate to the cloud. Where people just do this because they have done it the way they did for the last 20 years. So think differently is what I'm all saying, is use this framework to think critically about what you have. With that, I will change and go back to what we were in that. There is a little video to help you with that, but I'll proceed forward in that segment. So enough of business discussion. Next, in this video, you will find some more discussions about understanding the requirements of performance for applications. So there is another long video, apparently it's 20-minute long. So you should watch that later. I'm skipping that primarily because I want to talk about real use cases. And so here is a case, which is, you probably know this, it is the Netflix company. The Netflix company is the case that I want to begin discussing. So you know Netflix. I think most of you have accounts with Netflix. And so the users benefit from Netflix essentially boils down to something like this. That you have a huge collection of movies. You want to be able to watch any movie anytime you feel like, any location you are at, any device you have. That's the expectation people have these days. It was not like that just a few years ago, by the way. Just a few years ago, Netflix did not even exist. About 7 or 8 years ago, there was this thing called, where did they go? Yeah, here. There was this thing called DVD in the mail. You may have heard of or maybe used it. There used to be a Renton center where DVD used to come from in our area, in where I live, actually. Maybe different for different areas. But that DVD used to come in the mail that looked like this. There used to be a thing called Blockbuster that doesn't exist anymore. It is dead. And that thing closed. Do you know why it closed? Why did Blockbuster close?
Because of Netflix.
Yeah, because of late fee.
Right.
Yeah, they used to charge a late fee. It was evil. Evil is like being polite. When you get a movie, rent from this Blockbuster thing, and then you return it and you're a day late, they'll charge you like an arm and a leg to return that late DVD. that was the thing that Netflix saw, that as an opportunity that they can probably remove the late fee. So that was the biggest selling point for them, to remove late fee. And they started this business. This business was not an electronic business. I mean, it was online, in the fact that you were able to select a queue of DVDs you want to watch next, but that's it. And those days, Netflix had their own data centers. In their data centers, they had an interface where you can actually put a list of movies that you want to watch in the queue, and you have 1 at a time, 2 at a time, 4 at a time DVDs out in the mail to you. You return it anytime you feel like, no late fees. And that was the model. That was the model. And they gave you this thing called what I call a long tail. Do you know what a long tail is? What is a long tail? A long tail is basically a gigantic selection of assorted variety of DVDs available to you. So you have a huge collection of things, like in the example here, products. Not all of them are very popular, but some are really, really popular, whereas others, nobody cares. Like the exotic Indian movie that only I watch. I mean, I don't even watch movies, but I'm just saying. But those movies probably belong somewhere here. And certain movies are really popular. They are read the popularity is heavy. And as time progresses, those newer movies will go out in the long tail and sit somewhere here on the chain. That's the concept of a long tail. So if you compare this Blockbuster store and try to compare that with your Netflix scenario, the distinct difference that Netflix had was long tail. The problem that Blockbuster had was they were not able to store like those millions of movies in every physical store. They could not. So they were limited to only the highly popular movies that month. And you store only those movies in your store, and then that's why you have to have a late fee, because you want everybody to be able to get access to those top movies that are popular these days. So you charge late fee so that you force people to bring it back. What Netflix did was a slightly different game, and they introduced this idea of a choice, a selection. You can choose whatever you want, and it used to be surprising to me those days, 7 years ago, that I can get exotic Indian movies in Netflix. And not just Indian, you can talk about other countries. They were also there. By the way, India is the single biggest producer of number of DVDs or movies on the planet. It beats Hollywood left and right. I'm not saying in quality, just quantity, just bad movies. Lots of them. And we have what is known as a thing called Bollywood, Tollywood, Lollywood. God knows how many woods we have. Every city that produces regional movies, they produce so many of these, like 7 or 10 every week or something like that. Crazy numbers. But yeah, so that makes long tail. And this is just India, by the way. There are many other countries worldwide. So you have a huge collection, and Netflix used to carry that. That's what they used to do. And what they wanted to eventually go towards is a scenario which we today have, which is get rid of the DVD. Ubiquitous anytime access to all that movies that you have on your devices of choice. So that's the ultimate direction they wanted to go. So in 1997, you had, of course, Hollywood Video Gallery or Movie Gallery, or God knows what names were there. I don't even know. I'm not seen these names, Movie Gallery, but they probably existed. So the red envelope that you probably recall, which is this one, the red envelope, this used to exist. And at that time, Netflix announced a $1 million prize to help with what is known as the recommendation algorithm today. So if you remember this Netflix $1 million prize, this is the Pragmatic Chaos team that won that $1 million prize. Oh, that link is dead, huh? Okay, but that basically these days is known as collaborative filtering algorithm that you already have in case of predictions as to what movie you might like once you watch one movie. This algorithm eventually helped Netflix get users to stick on to Netflix platform because Netflix was able to predict what movie you might want to watch next or you might like. That recommendation method came along through this grand prize that was in 2009 was awarded to this team of collaborative filtering algorithm that they created for Netflix and gave it to them. That's how their filtering algorithm was developed over time. You probably know this intuitively. You expect this to be something that shows like people who watch this movie also like that movie, and that is based on filtering of people of similar characteristics like you have. So if you have something that you like or watch, or you have a specific behavior pattern of watching certain things, they will identify similarities with other people in your area, maybe in other places that have similar interests, and will look at their historical patterns and are able to come up with collaboratively come up with a recommendation for you. And that was one of the reasons why people kept on going to Netflix, because they always found something interesting, even though you may not remember that name of that exotic movie that fits in the long tail, and it's hard for you to search and try to remember. Having the idea of having somebody like Netflix come up with that recommendation. So you watch this movie, now watch that movie. And people were quickly adding it to the queue. And that's how the stickiness of the platform improved. Having talked about the long tail, let us see what they really eventually wanted to do. Because as you have DVDs, they were also running into problems. Those problems involved things like, people were pirating. You can actually copy DVD. If you did not know, it is unlawful to copy, but there is an open source product available to that effect. That's called DVD John. There is a guy by this name, John Lech Johansson. He is known for, his name is DVD John, by the way. And this guy created this product called DCSS, which decrypts DVDs and is able to create a copy of DVD. This is, by the way, in open source. So you can get this in Linux. And there is a fair use law also that I think you should remember. There is a fair use law or case law or doctrine it's called. So read that doctrine and do not pirate. It is possible. People have pirated. Do not pirate. You know that. I'm just saying. There is in Linux, it is easy to actually copy a DVD. And it is, according to case law, it is okay to copy DVD for personal use. Having said, people were pirating this. And so FBI got involved and a bunch of other things happened. So they wanted to reinvent their business model. The model eventually what they wanted was to deliver movies as an experience to you on your device, like you know already. That's what they wanted to do. And they wanted to see what makes sense. Like, we will have to have a setup in which we will have movies stored somewhere and delivered to your device, iPads, iPhones, Macs, PCs, God knows what you have, Samsung television, something like that. So what we are discussing in next essentially is those two things that are needed. So this is you, and this is the company Netflix, and they have this huge collection of movies. They're storing it somewhere. And what they want to be able to do is have you select any movie that you have, and it should just play on your device. And for that to happen, there are at least two things needed. One of them is something on the back end that will render the experience. And the other thing being on the client end. You need to have something with you. What is that thing? So that you can see the movie yourself. Like, what is that thing? Today, it is the iPad or the Samsung television or a bunch of other things that you watch, Xbox, Nintendo. Those are the client devices. And the back end needs to exist. They did not have that at that time. So the discussion we are having essentially is who will manage the back end streaming? And what devices will users watch the streaming content on? Like what devices existed at that time? And then should that client experience that you have. So for example, if you go to the App Store, and you will find that today there is this app called Netflix, and you can download it. Where is that Netflix app? Is there no such thing? Apparently there is no such thing, or maybe there is. Is it this? I don't know. I don't know which is the right watch Netflix movies. Maybe it is this. Maybe it is not. But let's go to netflix.com. They will tell us what that application is. So netflix.com. Oh, it's only the iTunes App Store. So it's in the iTunes Store. So there is an app that you can use in the iTunes in the store that will open up eventually. That is the Netflix app. So I can download it and I can then use that app. This is the client application experience that you want to see. That's what I'm discussing here, which is on the client end. The example that I just showed you was this app that will run in iPad or iPhone or something like that. There is also should be an app on the Macintosh itself, or maybe there is just browser-based interface. So one of those two methods that you can use on the client end. Now, the questions that they were discussing, and I would like you to answer those questions, which is, should Netflix create your own box at that time? Is it worthwhile creating a box for Netflix, or should they use the existing boxes people have, such as the iPhone or a television set people have? What should be the right strategy? And if they decide to go and partner with these box manufacturers, like we used to have Xbox and Nintendo Wii and PlayStation, so should they partner with these device manufacturers and have the Netflix app preloaded? Or should they create another box called Netflix box and go that direction? So if it was you, how would you decide those things? Should we have our own box or not? What would you go and think in terms of deciding whether Netflix should make its own box? Like some people have made their own boxes. You may have heard of this thing called, what is it thing called? Roku. Roku has a box, apparently, right? So there is a Roku TV box. You can buy this box. So they decide to buy or create their own machine that looks like this, right? This is the Roku box. So Roku decides to create their own box, but Netflix does not. Do you know why? What do you think that Netflix did not create a box like for themselves? What may be the reason?
Less expensive to spin up cloud.
Yeah,
More or less.
expensive to spin up a box, actually. You're really creating a device, and then you have to manage the device, service the device. And you know what? The biggest challenge that Netflix had was that you have to connect this device to a television. And a television typically has 3 or 4 HDMI inputs. And it is quite a bit of pain to change those inputs, honestly. Most of us have TVs and, we have those inputs, and it's a painful process. I mean, it's a hassle. I should not say pain. It's a hassle to go change the cable. And most of these slots are occupied by, people have their Comcast boxes, their Xboxes, Nintendo Wii's, they're occupied already. So you want to add one more thing like this, Netflix box, it becomes a hassle for the customer, end user, and you'd want to avoid that. Instead, use the machine that people already have. For example, the cable box or the game console, they exist already. Why not have our application get installed on the Xbox itself? Is the direction that they chose, which is to have the application itself run on a partner device.
It saves the initial cost of a device. Like with the Roku, you have to spend $50 or $100 to buy a device.
Correct.
Versus with Netflix, you don't have the initial investment, and you can get more people to try the service.
Yes, that's another reason. So, the initial upfront cost is expensive for the company. The company may decide to make it free if they decide that direction, but that becomes expensive. And so instead, partnering with existing players that already exist in the industry, like Xbox, PlayStation, or Samsung, or a bunch of other players these days, At that time, they did not create an Android app. They had an iPhone app. They had a support for Windows, support for Mac, but it did not work on Linux. It could work on Linux, but they did not want it to work on Linux. It could work on Android, but they did not want to work on Android those days. By the way, these days there's an app for Android also. And so what were the reason behind that? That you want to work on Windows and Mac, but not on Linux. I know it works. You can get it to work, but they don't want to. Do you know why? Piracy. The single answer is, simple answer is piracy. And another answer is that nobody actually uses Linux box to watch a television. There are a few, by the way. I used to be one of them. There are a few that exist, but not many people use it like that. And it is easier to pirate on Android than on a logged device like Apple. It is logged up. You cannot really hack into the back source code and make modifications to the flow of a video, that you can make a copy of the video that you receive. So those are the things that the creators of those movies actually prevented Netflix from delivering it on an Android platform to begin with. But over time, they have actually made an agreement with them. So we'll talk more about that. Now on the cloud side, on the back end, what do you think should Netflix do? Should they set up their own data centers, or should they go entirely on the cloud? And we know the answer these days. It's already well known that Netflix runs entirely on the cloud, on the Amazon cloud to be specific. And so the question that they were actually asking is, who will manage the back end? And who will maintain and keep the data center up and running and all that? And how do we deal with growth? Because growth will happen eventually. And if it grows beyond what you cannot easily add data centers left and right. That's something that you already understand, that it becomes really expensive. So that's one of the reasons why what Netflix did, what they did was to go entirely on the cloud. And what we know now is already understood. So back in another slide I have, which is the next one, which is what I want to go and discuss a lot more detail in terms of, I'm skipping some things here. I'm trying to look for that slide deck that I could not find. That's not a big deal. But if I find it, I know there are some pictures that I want to show, otherwise I'll draw them by hand. So here are those slides. And no, not this, not this. I think those slides are not the right ones. So I'll draw them by hand. The real problem that Netflix has is something like that shapes up like this, and I'll describe what they really want to accomplish. And we'll go a lot more detail in terms of understanding what does it take for a user, which is people like you and me, and we have these devices in our hands. So variety of devices that we carry these days. We have iPhones, Androids, laptops, and PCs, and Macs, and televisions, and Xboxes, and a whole list. In fact, that list is published here on the Netflix website, for example, Netflix devices. And so you have a site dedicated to that exact thing. We have smart televisions, streaming media players, game consoles, set-top boxes, Blu-ray players. So lots of companies that actually make these things, and they have a good selection of things that runs Netflix. You can see all of them here. And so a variety is there, but that variety comes with complexity, as you know already. That variety comes with complexity in the fact that what we are dealing with is that every device will be different. Like you have devices, let's call them D1, D2, like that, and D37. So lots of them. Like every device will be unique in its resolution. Some devices are 640 by 480, like that. And some devices are even different. So let's go see all the possible resolutions today supported. For example, here, if you go to display resolution and you look at this picture, you will find it has a huge collection of all the resolutions available in the market today. Except it doesn't include my monitor, which is a 5K. The biggest one you see here is a 4K. The all the way from the top, sorry, all the way from, give me a second. Where is the, hold on. I think I need to open it up again, apparently. Or go back a button and then go full screen. Yeah, so all the way from the top corner here to the bottom, if you now compare, you have this 4K resolution that looks like, oh, I think I need to download the picture. Hold on, let me download it quickly. So save image to downloads and then open it up in downloads. Like that, that's much better. So you have the whole picture. And here, if you look at this segment here, which is 4096-2160, that's the 4K resolution. Classic device, old laptop will be something like this, 640 by 480 VGA resolution. Old laptop or old television will be like this. Indian televisions are like this, PAL. Japanese televisions are like this. US televisions are NTSC. Where did it go? Yeah, it's hiding somewhere here. And you have classic newer laptops are this. And some of them are this size. Some others are this size. So you see so much variations as you go along. And the biggest ones that you have are 4096K, 4K. That's this size. So a variety of different resolutions that you see are there in this collection of devices that Netflix has to worry about. It's devices. And customers expect that they can see the movie that they want to watch on all the devices, all of them. That's the expectation. And so we talked just about one aspect of a device, and that aspect was the resolution aspect. It can vary from something like 640, 480 to 4160 by 2190 or something like that, if I remember right. 2160. So that's the resolution we have. This is the 4K resolution. People typically watch anywhere in between. That's just the resolution. Now let's look at some of the other characteristics. There are 2 or 3 more critical aspects to this movie watching experience. And they are, apart from the resolution aspect, the video codec used, the audio codec used, and the refresh rate. Refresh rate that is considered good enough that you can actually make a movie look like a movie is 25 hertz. If you go below that, people can detect that it is a classic jagged motion. So slow frame rate, like if you remember old style movies like 1800s, 1900s movies, they were a little bit of, low frame rate movies. So I would like to see slow frame rate video. It's hard to find those examples, but you may recall old movies, old 1900, early 1900 movies were, somewhat different than what we expect to see today. Smooth motion, the motion of a person moving his hand would look like something like this. You may have noticed movies like that. Old days movies used to exist like that. That was a reason for the refresh rate being less than 25. If it is less than 25, human eyes can detect that it is not a smooth animated motion, but a sequence of pictures. Sequence of pictures. It will appear to be a sequence of pictures coming at you. 1, 2, 3, like that. And if you make these sequence go more than 25 pictures in every second, and that makes a movie, a smooth animation movie. And that is what one of the critical aspects in showing a movie on your device is to make sure that your refresh rate is at least as high as 25. Now, about audio and video codecs. You may know these things probably, but I'm just calling them out. You may have heard of this thing called MP3, right? You may have heard of this thing called M4A, or something like WMA, or some of you may have heard of WAV, AIFF, or OGG. How many heard this? This is an open source audio format. This is not open source. This is Apple. This is from the MPEG consortium, MPEG LA, the association that controls that format, the codec. This is Windows, Microsoft. This is open, but it's very long, very, very big file. So it's big file. That's a problem. This is also a big file, another problem. So when the file of an audio becomes really big, it is really difficult to transport on internet. So you want to keep it compressed, keep it small. That's the whole purpose why these files are raw, not compressed. These are compressed. This is also can be compressed. There is another, FLAC, also open source. And there's also audio, and this is lossless. So when you compress the sound from a raw format, you introduce some loss. In these formats are lossy. But FLAC is lossless. So just giving you some flavor of what types of codecs that we have to deal with, because these devices that we are dealing with, each and every one of them, depending on the manufacturer, will support one or more of these formats and may not support the other formats, may not even work with some other formats. So you cannot arbitrarily send a WMA file to an iPhone. It will not play. You cannot arbitrarily send an M4A file to a Windows PC. It may or may not play, but these days Windows does. Windows 10 does. And so the concern that you have to really worry about is that appropriate supported codec has to be made available to that target device, which will vary, by the way, on demand. Suddenly people will change watching on a big TV, and then I have to go. So they just pause the movie, sit in their car in the back seat. Somebody else will drive, and they will expect to continue to watch the movie on the iPhone. It's expectations, right? You have to meet those expectations. And you will also have to meet that expectation of having to remember which position I paused and continue forward from that point onwards, not having me to go and skip ahead into the movie to remember what point I was at. And that continuation of experience is a difficult thing to accomplish, but it is needed because people expect it. People also expect to never, ever call Netflix to say that your service sucks. How many of you have actually called Netflix saying, hey, your service doesn't work? It probably did not happen. Maybe once. I have never heard of anybody actually making a phone call to Netflix saying, your service doesn't work. Have you ever seen or did such a thing? Like most of you actually use Netflix apparently, but have you called Netflix saying, hey, your service doesn't work? How did it never happen? I mean, I'm assuming.
People don't have the time. They would basically cancel the service and move on to another provider instead of calling them.
Yeah, so it typically turns out to be a provider problem, a Comcast problem, or a Verizon problem, or a AT&T problem, as opposed to a Netflix problem, right? It's a pipeline problem as opposed to the content problem. So
I think when they were down for a day or 6 hours in Asia, when that thing happened with Zero.
Yes, couple of times there have been outages, no doubt about it. There have been outages.
The router was bad or the wireless was bad.
Yep. So
I mean, if you compare Netflix service to Amazon streaming service, Amazon streaming service is bad.
I know. I agree. And I know the people that work in that team, by the way. I'm going to complain. I have been complaining to them, but I'm not a big TV watcher. So, but you're right. There is a reason why Netflix works the way it does. And we'll talk more about those details as we get to that point. So I'm basically giving you the perspective on understanding the complexity of a problem that Netflix is attempting to and has considerably solved. And that's what we are beginning to understand. What are they really trying to accomplish for the user? And then we'll go and go dig deeper in terms of what does it take to build such a thing, that's the discussion I want to have. It's a fairly elaborate, in-depth discussion I want to have so that you get a good, solid perspective on what does it take to build something for real. That's what I'm going to show you in a discussion format. To the extent I can actually demonstrate, I will do live demonstrations also, but it is really difficult. Some cases are really exotic and esoteric. I cannot pull it off for a real live demo, but to the extent I can, I will. And at least I'll give you the detailed clarity of understanding to make sure that you clearly get this scenario of how does Netflix do what they do. So this is the discussion on audio codecs, right? There is another thing called video codec that you have to worry about, and that is something like MP4 file or MOV file or WMV file. You may have seen this, right? You probably have seen a file like WebM or Theora, or there are other formats like Matroska, a bunch of other formats, video formats. So you may have seen these names of video codecs. AVI is a container format. So lots of things that you may have heard of these things. Some of them are familiar to you, some others are not. This is probably well known. MP4 video. This is the Apple format for videos. And here is the Windows format for videos. Here is the Google format for videos. Here is the open source format for videos. Here is also open source. So lots of different formats, and all these devices that we are discussing about cater to some, but not all formats. So not all formats of video codecs, not all will work on every device. That adds to the complexity that Netflix has to worry about. So that's the client endpoint, client side complexity. So now when you want to actually deliver a movie experience to, let's say, D1, D2, all the way to, let's limit ourselves to 37 device types, for example. There may be more, by the way, but just picking this number randomly, arbitrary, 37 device types. In each one of them might have a unique screen resolution, a codec for video, a codec for audio, and a frame rate. At least. There are more characteristics, by the way. We have to keep track of the matrix of complexity. For these many devices, these variables we have to address and create video formats to service and play on those target devices smoothly at all times with no jitter and no lag and no latency. And these things we need to accomplish. That's the complexity matrix that Netflix needs to deal with, at least from this perspective. Now let's look at where the movies come from and what does Netflix really do from a pipeline perspective. Like they have a supply chain, they have their suppliers. Pretty much here is Netflix. You are the customer. They have their competition, which is Amazon Movies, or Apple Movies, or some. Maybe Apple is not strictly a competitor, but Amazon, what was that called? Amazon Video, you said? Amazon Video is a competitor, for example. And there are more, Hulu, like that. Many other services that provide content, they compete. Then there are partners. Who are the partners here for Netflix? Amazon Web Services. They use their cloud. So is it a partner or is it a supplier? I would call them a supplier. The Amazon Cloud, AWS, will be an input to the Netflix service. So who are these guys? This is you. This is Amazon Web Service. This is also, places like Hollywood and places like Bollywood and all these other worlds worldwide that give them movies. and Amazon gives them the cloud. Who are these guys? Anybody?
Probably the Kodak guys.
Marketing? I don't know.
Yes, marketing are done by these company itself, right? Company will market itself. And so these are complementors. And these are things that make Netflix suddenly interesting to you. What is that thing? It's the iPhone. Otherwise, how will you watch Netflix, right? The iPad, the Xbox, and all these devices that you use fit in here. The fact that you have those devices makes it possible for you to watch Netflix. Otherwise, how will you watch it? So they are the complementors with the E here. And so they help Netflix deliver the experience to you so that you, if you have an iPhone, an iPod, or one of those devices, you're very likely to indulge in watching Netflix. Likely to. So you become interested. That's the picture from a co-opetition perspective that we are looking at. Now, if you look at Netflix's pipeline, what are they getting and from where they're getting and how do they come to you? The pipeline begins with, let's say, Hollywood. And in there, they will create movies, for example, La La Land. The movie gets created. Now that movie is shot in a large screen format, very large screen. So for example, the biggest screen that you can think of today in our nation is the IMAX screen. It's a really gigantic resolution. An IMAX screen resolution is something like 18,000p as opposed to 5K, which is 5,000p, or 4K is 4,000p, and 720p and 1080p, like that. These P's are horizontal lines, by the way. So if you look at a picture on a display, these lines that a picture will be drawn using, you count them 1, 2, 3, 4, like that. And a 720p video has 720 lines. And a 4K video has 4,096 lines. Where is that? Yeah, 4,096 lines, horizontal lines. Or rather, I'm sorry, I'm wrong. I'll repeat what I said. It is 4K is not 4096p, but it is 2160p. So I'm correcting myself. This 4K is not 4096p, it is 2160p. And 5K is not 5000p, but 1080p is 1080. This is correct, this is correct. This, I don't know what that number is, but let's find out. So resolution, display, no, display, and the resolution would be something like, change it. What was that number? 1800p. Okay, the number was 1800p. And I think I must have messed up my video recording, by the way. So sorry about that. I messed up already. So which means your video will look really ugly for this session. I can address that by stopping the recording and make it into 2 parts if you like. So the rest of the discussion will not be ugly. I think I should do that. So I'll break the recording, make 2 videos, one for up till now and one from here, this point onwards. So stopping recording,